Hey gang, how you doing? Week 7, the week that cares. All right, so what does week 7 have in store for us? I don't know what that means. Made up that on the spot. So week 7, what does week 7 have in store for us? Week 7 starts on page 65 in your book, 65 if you're German. And for the 65, 65, 5 and 60. Anyway, huh? Yeah. I shouldn't have said that. Anyway, I'll edit that out later. So alternatives, so the design team is who's watching this video, right? Because this is the alternatives video. But the design team, you've got 3 videos to watch this week. Alternatives, this video. The next video you should watch is ConOps. And then the other video is the payload status review preparation video. That's a video for everyone to watch this week. You guys can watch that at the beginning or at the end, whatever. But please watch alternatives before you watch ConOps because they kind of build on each other. So this is alternatives. And again, 65 is where week 7 starts. Page 67 is where the alternatives section starts. And what we're going to talk about today, alternatives are really important. And I don't want you to think that the shortness of this chapter or the shortness of this video, hopefully it's short, I don't want you to think that alternatives are unimportant because of how short this content is. They're very important. They're probably the most important thing in engineering. Because more engineers have a problem, and I admit that I have the same problem. Is that engineers, we come up with a solution a lot of the time. We figure something out. We find a solution, and then we put blinders on, okay? And then we're like la 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 la. I can't hear you, la 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 la. And you don't want to listen to anything else. You don't want to hear anybody else's opinion about your design or any other possibilities. You just la 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 la. That's what it was. You just chug down, you're like, I'm going down this road no matter what happens. NASA does this quite a bit actually, and it's not great. It's not a good thing to do. You want to always keep your eyes open, your mind open for better solutions, alternative solutions, okay? There's more than one way to accomplish a science objective, to accomplish your science objective. There's more than one way to do a lot of things. So that's what today is about. Today is basically saying that take a step back and look around to see, open up, take the blinders off, open up the possibilities and see if there's any other solutions out there that you just have not thought of yet. Very important stuff. Okay, alternative designs. Alrighty then. So outline, you're not supposed to be able to see this video, that you can go download this video, this presentation, you can download the video too, but the presentation is on the downloads page of the Inspires website, so you can download it and follow along. But today we're going to talk about, we're going to do this as an example. So I've got sort of some science objectives. We'll go through the alternative design, the process that you go through. We'll talk about the group candidate designs, what you guys want to get out of your alternatives so that you can later compare your alternatives, and then a wrap up at the end. Again, the whole purpose of alternative designs is just to see if there's better solutions out there. And so keep your eyes open, keep your mind open, and don't be scared to just throw out ideas. Some of the best ideas we've had, or that have come about from design, have been someone just saying, hey, what if we did this? And then someone's like, that's not a bad idea. Another person's like, that's a good idea, let's try that. And they go with it, and it works out working great. So keep your eyes open. So everyone has a science objective so far, correct? Yes, good. Because if you don't have a science objective, pause this video and then come back when you do have a science objective, okay? I'll wait. Okay, so everyone's got a science objective. Now your science objective should be clear and concise. It should be something that everyone on the team understands and that you know what it means, okay? That might sound silly, but sometimes we talk to teams and half the team thinks the science objective means one thing and the other half thinks it means something else. That's not a good thing. Everyone needs to be, hand in hand on the science objective so that everyone knows what it means. Clear, concise. Don't assume a solution with your science objective. Your science objective should not be, we're going to go to Europa and dig a hole. That's not a science objective. That's a solution. Digging a hole is a solution. We're going to go to Europa and study heat flow. That's a science objective. If you dig a hole, that's a solution. I don't know if you're going to dig a hole for that, but so you don't want to assume a solution. You want to take a step back, make sure that you've captured the problem, and you don't have any solution assumed in your science objective. Excuse me. Last thing.
Can.
Huh?
Can we dig a hole?
Yeah, can we dig a hole on, that's a question. So can we dig a hole? I don't know. So keep your options open. Again, and engineers are terrible at this. Male engineers are the worst about this. I admit it because I'm one of them. We don't take too kindly to suggestions a lot. I don't like it when people poo-poo on my ideas. That happens to me quite a bit, actually. And I think I'm gonna go, huh? Poo-poo, I know. Sorry, Leo. So keep your options open, and remember, it's about the design, it's not personal. So here on this science objectives slide, I have some pictures of, or some illustrations, or renderings of Europa. Your science objective is going to have to deal with Europa or Saturn or somewhere in the space around Europa and Saturn. So hopefully your science objective is concise and clear, everyone understands it. So, okay, so what's the process? The process for all this, and I've got two, okay, for this example, our science objective is to look at heat flow, is to look at heat on Europa, okay? What's the temperature on the surface of Europa, basically? That's what we're looking at for this, for this one. And what you guys do is you break up into two, you have one team, right? And so our science objective for this example is heat on the surface of Europa. And you guys break into two groups. Typically the PM takes one group and the chief engineer takes the other group, okay? So you split up into two groups, and each group comes up with their own solution to that science objective. You come up with your own alternative that it can accomplish that science objective. You got to make sure that the alternative accomplishes the science. That's very important. You have to each of these solutions has to accomplish the science objective. Okay. So here I've just drawn two alternative ideas to look at heat on the surface of what temperature on the surface of Europa. Here we've got a missile-shaped device that falls off of an orbiter and hits the ground and buries on the ground. Okay, very simple. Here we have a spherical-shaped device that falls off of the orbiter and bounces and hits the ground, right? So two different solutions. They end up, they have similarities, they do have similarities, but they have differences as well, okay? Some, one buries itself on the ground, one bounces along and then just rests, comes to rest eventually. So that's what you want, that's what we want you guys to do. It's talked about on page 67 in your book. So PM's group, chief engineers group, you guys come up with different alternatives. It says brainstorming is encouraged. You guys want to, when you get in your smaller groups, brainstorm. Think of ideas to accomplish this. You don't want to, I'm sure you have ideas already to accomplish your mission, to accomplish your science objective. Put those to the side for the time being, and think if you can think of some other ones. There might be a better idea just around the corner, and you just haven't put your initial thought down yet, so that the better idea could come up to the top. So you want to make sure that you explore the entire design space while you're doing this. So so split into two teams, and then you come up with designs, ideas essentially. And so what do you want to do with these? These are called group candidate designs, by the way, because there's the PM's group and the chief engineers group candidate designs. And so once you have your group candidate designs, you want to kind of flesh those things out. What are they going to do? What components do these designs have? Do they have the same components? So do you have a mass spectrometer in one and a thermocouple in another? Do you have accelerometers and IMUs? What's the difference? So you want to fill out this. There's a table. The table is on page. You can sketch your design out on page 68 in the book. On page 69 in the book, you can fill in. We ask you for each of these candidates, for each design. So for the PM's design and the chief engineer's design, fill out this table as best as you can. Okay. So what are the components that are required for your group's design? What's the number of those components? The masses, the power levels, total mass, and total power. Okay. So if you have 4 accelerometers, then you multiply the mass by 4 and the power by 4, and 4 thermocouples, whatever. So you want to get a rough estimate of masses and power levels for each of the designs. Okay, and it's important to do this. You want to have each design to the same level of fidelity. What that means is you don't want to have one design to say like, this is our one alternative. We have a CAD drawing of it. We see this every year, by the way. Okay, when the teams present every year, it's kind of funny, but every year the teams present their 2 alternatives, And they go, here's alternative 1. Here's our CAD drawing. Here's the mass specs on it. This is a beautiful rendering of it. You know, and then they go, here's alternative number 2. This was sketched on a napkin, okay? And so, and it's obvious that they favored one over the other, okay? So you don't want to do that. You don't want it to look like you favored one over the other, even if you do. But you want to treat treat your alternatives equally, okay? Because again, you might stumble onto something that is valuable, okay? That's what we're doing. We want to make sure that there's not some valuable stuff that we haven't thought about yet. And what's really cool is that actually more often than not, you end up combining your ideas together. You take good ideas from all over the place and put them together and make a nice and make the best idea. So you want to have these specs for each idea, for each concept. You want to have these specs. Page 70 rather. This is the tough part. Okay, so the chief engineer took a group and they created their group candidate design. They filled out the table that was on this, that was on page 69 in the book. The PM has a group. They came up with their idea and they filled out the same table. Okay, so we've got we've got 2 designs, 2 alternatives. The chief engineer's group, the PM's group, and they have the specs. Everybody's group design is kind of designed to an equal level of they're kind of equal in design resolution or detail. Now what do? You come back together, okay? You come back together as a large group, and basically you start throwing rocks at each other, figuratively speaking, okay? You don't throw rocks, that's bad. But what you want to do, you come back together, and you openly and fairly discuss the ideas. This is the hard part for engineers, okay? I'm one of the worst, okay? If this is my idea, I will take my idea and be like, you get away from my idea, and you start kicking, you get away from my idea, So you don't say bad stuff about my idea. I spit on you, It's not about the idea. It's not personal. You got to put your idea out there on the table. Let people poke holes in your idea. If your idea is good enough, it'll survive. Okay, it's not a personal deal. It's about finding the best design. Okay, so you put each idea out there. The chief engineers group, the PM's group, you put them on the table, figuratively speaking, and you guys start listing pros and cons. That's what this table's about, okay? You have concept 1 and concept 2. You want to name them, come up with some neat names, stuff like that. And then you have the positives for concept 1, the positives for concept 2, and then the negatives for concept 1 and the negatives for concept 2. This is a hard activity for some people because they take it personally. It is not personal, okay? Again, it's about the design, it's not personal. So just put your ideas out there and poke holes in your own idea, okay? Because as someone starts talking about it, you might go, oh my gosh, there's some stuff that's bad about this I didn't think about until just now. So it's about the team because, you broke into 2 groups, but you're back together as a single team. And now that single team's objective is to come up with the best design possible. And the best way to do that is to openly, fairly, and critically look at these 2 ideas, okay? And also, as I said before, more often than not, teams start taking bits and pieces of ideas and put them together and form an ultimate, the 3rd idea that just rules them all, okay? So that's why it's important to be fair and to be critical about the ideas and honest, okay? So list the positive and negative. There's a table. You can use this table. This is in PowerPoint. It's editable. So just take the same table, take out the blahs and all this stuff. Take all that stuff out. You can use the exact same table. And engineers like tables. When you present this to us, use the table. I said the word table 8 times in the past sentence. Okay. So basically, that is it. That's what you do. Is you break apart into 2 groups. Each group comes up with an idea. Bring it back together. And so, in a nutshell, there's more than one way to skin a cat. I like this phrase because PJ hates it, and I'm allergic to cats because they're evil. And anyway, there's more than one way to accomplish your science objective. You guys can. There's a bunch of ways. There's more than 2 ways actually. You'll see this as you start to do this exercise. And then explore the design space. That's a phrase. But the design space are all the possible ideas that can solve that can accomplish your science objective. And you want to come up with just 2 of them. Just think of 2 of them at least. The more the better, I think, actually. You want to brainstorm. When you're doing this, brainstorming is very important. in a brainstorming activity, you need to be, you can't be critical of people. You can't, when someone throws out an idea, you can't go, that's stupid. That's not cool. Because sometimes stupid ideas are the ones that end up working, okay? For starters. And also it just, that inhibits the creativity in the group. You want the group to be creative. You want the group to feel like they can say anything and just come up with any idea. And that's the whole part of it. So you don't want to be critical during the brainstorming phase. Just write them on the board and explore them later. New ideas are what you want. Outside the box, you don't want to. I know you have ideas already about everyone's got ideas about your alternative, about your science objective. Forget about those for the time being, come up with new ideas. But you must satisfy the science objective. That's the most important thing. If you can't accomplish your science objective with your ideas, then it's not a solution. It's not a candidate solution, okay? Then come back together, be honest, critical, accept criticism. That's the hardest part for people, accept criticism. It's not personal, it's about your team coming up with the best design possible. So, that's it for now. This is the alternatives video. The next part of this is called concept of operations, and that's where we'll talk about ConOps, basically. And it's something that you'll also want to explain for each of your designs. Once you get to that phrase, once you get to that point, you'll have to explain what the ConOps are for each of your candidate designs. So, I hope you enjoyed this, and we'll talk to you later. Bye-bye.